Hey guys, welcome to part 2 of my Python tutorial YouTube series. In this video we're going to be going over data types and essentially just the different data types that come built into Python. They're all pretty straightforward, and I'm just going to go over the ways they differ and just which data types come and which don't. So just a quick note before we get into the actual lesson. I mentioned in the last video that beginners can and probably should be using idle, which is this editor or this IDE, to program in Python. It's very easy. You just create a new file, you type your code in here, save the file, and then go to run and run module, or I guess you could hit F5, and that's all fine and dandy. But me personally, I'm actually going to be programming inside of Atom here. Atom is a text editor that's a bit more customizable, and I've personally been using it for a long time. So I just prefer it over idle, and this is where I'm going to be programming all of my Python tutorial videos in from now on. So just letting you know. So everything I type in here can also be typed up in idle and run the exact same way. I'm just opting to type it in Atom just because I prefer it. If you guys want to use Atom, by all means go ahead. I'll leave a link in the description where you can download it, and I presume you guys are going to be using it to type up Python code. So if you are, then may I suggest that you get this package here, atom-python-run. It allows you to type up your Python code in a .py file. Just hit F5 and it will run. And we'll be doing that several times throughout this course of this video, so you'll see how it works. But anyways, let's just get into the video. So first of all, I'm going to put a little header here. Not a header, it's called a comment, but I'm just going to say data types. Essentially what a comment is this just any line that starts with this number sign or pound sign or hashtag, whatever you want to call it. And it just means that Python won't read it as a line of code. Even if you put actual code, as long as it starts with the hashtag, it won't be run as actual code, if that made any sense at all. But that's not too important. You don't even have to use comments if you don't feel like it. It's just a way of making the code a bit more legible. If you're collaborating with a partner, for example, you want them to know what the code is doing, so comments can help with that. Alright, so our first data type that we're going to be going over, integers. So I'm sure you guys have probably taken a couple math courses in your life. If you've taken anything past grade 2 math, I'm sure you know what an integer is. It's just a whole number, positive or negative, and it includes 0. So for example, if you have -2, -1, 0, 1, 2, any of those types of numbers going all the way out to infinity, technically you can't use infinity, but I mean it in the sense that you can use any whole number that's infinitely high or infinitely low, that can be considered an integer. So for example, we're going to be using the print function that you guys saw a bit of a sneak peek in the very first video when I printed out the hello world. We'll be going into functions and stuff in later videos, but for now all you need to know is that the print function is just print with 2 parentheses or curly brackets, and whatever you put inside of it essentially gets printed out to the console, or the output window I should say, to be more specific. So if we want to print an integer, let's just say print 1. So if we save it and run it, boom, as you can see, we've printed out 1. It's all pretty straightforward, but how do you know that's an integer, right? I'm going to introduce you guys to one more kind of handy function, and it is the type function. So we're going to print out the type. So I'm essentially putting a function inside of a function. So we're going to print out, here, I'll just sort of spell it out for you guys. So if I highlight this is type of 1, right? Similar to the way we used print of 1, we're getting the type of 1, right? But we're going to print out the type of 1 since we've put type of 1 inside of the print function. Make sense? Cool. So let's save it and run it. And as you can see, 1 is an integer. Ignore this class part. We'll get to that in a later video. But all you need to know now is 1, its type is an integer. All right. So that's essentially an integer. It's all pretty straightforward. The next one is a float. I don't have to put these spaces here, but I do just because it separates it a little bit. So floats are very similar to integers in the sense that they're numbers, but floats have a specified decimal. So for example, if you have something like 1.1, that would be a float. We can even print it out. 1.1, and then we'll print out the type of 1.1. All right, and if we run it, as you can see, it prints it out the same way as it would an integer, but its type is now a float. And a float, again, it's just a number that has a decimal. Now, you might be wondering, okay, well, if I were to print out 1.0, that has a decimal, but it's 0.0. Is that an integer or a float? It's actually a float. Despite 1.0 and 1 having the same physical value in the sense that the quantity is the exact same, since 1.0 is actually represented with a specified 0.0 decimal point, it's considered a float. And you can see that if we were to print out the type of 1.0, as you can see, it's a float. Just like that. So again, it's pretty straightforward. Just anything with a decimal, it's a float. If it doesn't have a decimal, it's an integer. All right, next data type. We have strings. So you guys kind of got a bit of a sneak peek in the very first video when I printed out hello world. The hello world was a string. Now, if I were to print out the same thing, hello world, as you can see here, I have used the double quotes or the quotation marks, whatever you want to call it. If I print it out, it just prints out hello world. Very simple, very straightforward. But there is another way you can print out strings. You can actually use single quotes. Whoops. Stupid autocomplete. Hello world. So if I run it, you can see it prints out the exact same thing. So you might be wondering, why would I ever want to use the other one? You know what I mean? Like double quotes, for example, you have to hold down shift and then hit it. I don't like using it. I like using the single quotes just because it saves me a button press and it's just easier to do if I am doing something with my other hand, or I'm, eating something, taking a drink. I don't know. Whatever I'm doing, it's just easier. You know what I mean? But there are some reasons why you'd want to use one over the other. And the biggest one for me personally is if I have a sort of string that makes use of one of the other quotations. Here, I'll just show you. I can barely explain it. So if I were to use single quotes and say, I don't like you. Well, I still have my quotes right here, but now I've used the exact same symbol within the string. So it thinks I've ended the string right here, and it's treating the rest of it like what? It doesn't know. So if I were to run this, for example, as you can see, it's giving me a syntax error. Now, if I were to change, well, not this. If I were to change this to double quotes, as you can see, the atom highlighting nicely shows you that it's treating it as a full string, and when I run it, I don't like you. Right, so that's just one of the many reasons why you'd want to use one or the other, because you can have some errors if you do opt to use one all the time. So just keep that in mind if you ever run into an error like that, or just a problem like that. All right, so those are strings. Now we have lists. Now lists are interesting. They allow you to contain multiple of other data types. That didn't come out nicely. It allows you to put in a list, for lack of a better explanation, a bunch of other data. So here, I'll just type it up and you guys can see. So a list is denoted by the 2 square brackets on the other sides, or on each end, I should say. And I can put, for example, I can put the string A, B, B, and C. And that is a list containing 3 items, and those 3 items are the strings A, string B, and string C. All right, so if I didn't want to save that just yet. If I were to run this, perfect. As you can see, it prints out the list A, B, and C. All right, so lists have some interesting properties. I know in other programming languages, lists or arrays or whatever you want to call them, I just said both of those because they're very similar. Sometimes they can only contain objects of the, or not objects, but elements of the same type. So in this case, we have a list of A, B, and C all being strings. But in Python, I could put anything I want inside of the list. So I could put A again, I could put 1, 2, 3 being the integer 123. I could put 1.2, I don't know, and print, and it's giving me a list still with string A, integer 123, and float 1.2. All right, so Python's a bit useful like that. And the last thing I want to show you with lists is that you can actually obtain the element at a certain index of a list. All right, so let me explain this. So this list right here contains 3 elements, right? But its index, or sorry, the indexes of each element are essentially an integer value that corresponds to the position in the list. So what do I mean by that? I mean, in this list of 3, the value or string A has an index of 0. All right, so the very first spot in the list is index 0. You would think it's index 1, but it's index 0. All right, programming is a little weird like that. But then that means the second item in the list is index 1, the third item is index 2. So let's say I wanted to print out A, for example, right, from the second list, let's say. Well, let's take the second list, and I want to say print, and I want to say print the list. So the way I get the index is I have the list, and then right after it, in another set of square brackets, I put an integer value of the index. So again, I want to print out A. A is in the first spot in the list, which means its index is 0. All right, so if I put the list at index 0, if I save it and run, it prints out A. All right, so that's essentially how you get the items of a list at a specific index. It's pretty straightforward, and it'll become a bit easier when we get into using variables. It'll essentially prevent you from having to copy and paste the list every single time. And variables will actually be very useful for all of these data types and many more, because we'll learn how to make our own later on. But for now, you don't need to know that. All right, so what is this? The 5th one? Tuples. So tuples work in almost the exact same way as a list. All right, so a list, for example, not even for example, we've already seen it. It's just a sort of storage device where you can hold different objects. But what I didn't tell you about lists, and this will become a lot more apparent when we get into using variables, is that you can modify lists. So I can't quite show you this right now, but I just want you to understand the difference between a list and a tuple. A list can be changed once it's created. A tuple cannot. So other than that, they're the exact same, but once a tuple is created, you cannot change it. So for example, ABC, this is a list. If I wanted to, I could change the first element in this list. Instead of it being the string A, I could change it to the number 2. If I felt like it, I could change it to anything I want. If I had a tuple of ABC, so for example, if I had this 1, 2, 3, all right, tuples, yes, they are created using curvy brackets, or not curvy, but like, what's the proper term? That was really weird to say. Curved brackets, parentheses, I don't know. I'm Canadian, not American. Anyways, yeah, I'll just say parentheses. But they're denoted using the parentheses on either side. All right, so they're the exact same. I could have 1, 2, 3, and I could also have print. I could do both of these, and they would work in the exact same way, in the sense that I could put any data type inside of them. I could pull the index at any value, and it would work in the exact same way, except if I were to set this to a variable and then change the index of that variable, again, you guys won't fully understand this, but just understand that a tuple can't be changed once it's created. If I wanted to change something in a tuple, I'd have to make an entirely new tuple with the changed information. All right, so you could argue that they're a bit less useful in the sense that you can't, or they have reduced functionality, but they do have their purposes, and that is one of the primitive data types that Python gives you. So yes, those are tuples. And if we print it out, actually, you'll see it's the exact same as a list, except it just has the parentheses on the outside. Perfect. All right, and last but not least, we have dictionaries. Dictionaries are incredibly useful. So dictionaries, these use the squiggly brackets. I don't know what they're called. But essentially how a dictionary works is you have a key and a value. All right, so essentially, here, let's create a dictionary. Let's say A is equal to, or sorry, A will refer to 1, B will refer to 2, and C will refer to 3. All right, so it's a bit of a weird notation here, but don't worry, I'll explain it. So essentially how this works is split up by each comma here are the keys and values. All right, so as you can see, this is 1, this is 2, and this is 3. All right, so over here to the left of the colon here, we have the key. So I've set the strings A, B, and C to be the keys. Now if I were to set this dictionary as a variable, actually I don't even have to do that here. Let me just show you. Again, it's really awkward having to do this because I would have to copy and paste the dictionary all around, and this is when variables really come in handy. But for example, if I had dictionary, or the dictionary here, and I wanted, so similarly to how we got the index of a list, we can use the square brackets, except instead of passing in an integer value, we pass in the key. So if I want to get the value 1 from this dictionary, I have to pass in its key. And since its key is string A, as you can see here, string A corresponds to 1, I would say A. All right, so if I save it and run it, as you can see, whoops, it prints out 1 right there. And that's essentially how you use a dictionary. But why are dictionaries important, right? If you need to have sort of a bunch of information that's stored based on a certain value, which is actually exactly what a dictionary is, you can just pull those values from the dictionary using its key, right? I basically just explained what a dictionary is. It's pretty self-explanatory, but the functionality of a dictionary, wow, I almost tripped up on myself there. Dictionary, the functionality of a dictionary is very important and incredibly useful. You can also get indexes of dictionary. You can say if things are inside of dictionaries, but again, I'm getting a little ahead of myself. Don't worry, all of these things will make much more sense in later videos, but for now I just want to show you the different types of information you can use inside of Python. Again, so here, let's do a quick recap actually. So what did we go over? We went over integers, floats, strings. I should make these all plural. There we go. That was bothering me a little bit. So we have integers, floats, strings, lists, tuples, and dictionaries, right? We learned how they all work. We learned 2 different functions actually. Granted, we will go into a bit more depth explaining functions in later videos, but we learned about print and we learned about type, right? And what they did. And I guess we also learned about comments, right? Just put the hashtag at the beginning and it'll act as if it's not even there. But that's essentially it for this video. I hope you guys enjoyed it and took something away from learning about Python primitive data types. If you liked the video, please subscribe, leave a like, leave a comment, whatever the heck you guys want. And I'll see you in the next video. All right. See ya.